Okay, so now we have a theory of computation that, in a sense, acts as a mechanical process that can explain or potentially explain cognition. Um, so, with this theory of computation, we can think of the mind as, in a sense, being like a computer. It's a formal system. So, the mind is kind of a computer. A computer is a formal system. And so, the mind might be like a formal system. So I'll tell you what a formal system is in a bit, but computers work by controlling the flow of electricity, but the result is that the computer behaves according to a logical formal system. So it's not quite the same thing to say that a computer is a formal system, but it behaves according to a logical formal system. Um, and these right here, these are actually logic gates. We'll talk more about them in this video, or at least in this lecture, but we'll talk a lot more about it when we talk about neural networks. So in any case, the idea is that the mind is also a formal system or behaves according to the rules of a formal system. And that isn't to say that we always behave logically, right? You can use a logical system or to program a machine that will give you illogical answers to various problems based on the rules it's programmed to follow. There are people who could program that kind of thing. Um, and so, in a sense, you could bake the illogical behavior or answers into the program. Um, so it doesn't necessarily mean that you have to be logical, right? Um, so it doesn't, and also it doesn't necessarily mean that we are logical, but in a very loose sense, it means that we're sort of made of logic. So our system is made of logic, even though we're not necessarily logical. That's the idea. And so what is a formal system? A formal system is a system that consists of what we call tokens. And these tokens are things that can be manipulated. And it also consists of rules for manipulating these tokens. So a great example is chess. Chess is a formal system, and each piece in chess on a chessboard is a token. And there are rules for how to manipulate those tokens, right? So pawns can only go, what, one square forward. I don't know what the horses are called, but the horse ones can move it like in an L fashion, right? And then the rooks can go, there's one piece that can go diagonal and another piece that can go horizontal and vertical, right? So that's the idea, is that each token has its own set of rules that can be applied to it. And so all that matters for something to be a token is that it has to tell you what rules will apply to it. So if you're a token of a certain type, it means that there's a rule that can be applied to that token and how it can behave. And the one characteristic is so one characteristic of formal systems is that the physical manifestation of these tokens do not change anything about the formal system. So you can contrast this with like a non-formal game like American football. Each player is a type of token, but if you put the wide receiver on the offensive line, your quarterback's probably going to get tackled very fast. That's because a wide receiver is usually much smaller in stature compared to an offensive lineman. So that matters, right? Swapping a wide receiver for an offensive lineman would matter. Or in basketball, if you swapped out the tallest player for the shorter one, this will make a difference in terms of how the game gets played. Whereas in chess, it doesn't matter. As long as the type of token tells you what rule can be applied to it. So a computer uses a formal system, but there are various ways to instantiate the formal system. So if the mind is a formal system that manipulates symbols, then it doesn't matter how the mind is instantiated in your brain. And this is one of the convenient things about a formal system, is that a formal system manipulates symbols, but it doesn't matter how that formal system gets instantiated in your brain. And therefore, the brain is not super relevant to understanding the mind, if the mind is like a formal system. So in the example of chess, understanding what the chess pieces are made of is not going to help you understand chess. It doesn't matter if the chess pieces are made of people, made of wood, made of metal. It doesn't matter. All that matters is that they are a certain type and you know what rules get applied to a given piece. And in the same sense, you couldn't figure out how a computer program works by just looking at the hardware. You couldn't figure out how a chess game works by simply examining what the chess pieces are made of. So, similarly, you couldn't figure out how the mind works by looking at the brain. The only thing that matters about the tokens is that they can instantiate the rules, not what they're made of. Um, yeah, and so of course it could be that each person has a slightly different formal system, and our minds have some variation, might have some variation like formal systems. Like my formal system might be slightly different than your formal system, or it could be that we use the same exact formal system but with slightly different tokens. So one of the aspects of formal systems is that they have a property which is called self-containedness. What that means is that the system operates entirely within its own rules and it properly functions without needing to reference anything outside itself. So the rules, elements, and operations are defined internally, and any reasoning within the system can be performed using only the system components. So chess, propositional logic, pure mathematics, these are all self-contained systems. Whereas something like Newtonian physics is not. And that's because Newtonian physics refer to things in the real world, and as such, it's dependent on the external world. So the way I like to think about this is, 2 plus 3 equals 5. That doesn't refer to anything external by itself, and therefore it doesn't depend on anything in the external world for it to be correct. It can be proved using its own internal rules of mathematics. And so similarly, a legal arrangement of a chessboard can be derived entirely by the rules of the game and nothing else. Okay, so let's stop here. In the next video, we'll keep going with formal systems.